In this brief video, we'll go over some tips and tricks. Well, some tips, like some general rules to use when you make data visualizations, some things to keep in mind as you go along, and some rules of thumb, basically a lot of them coming from Tamara Munzer's book. I'll go over each of these. So the first one is the data to ink ratio. It's important to have a high data to ink ratio, which means that the ink you use actually represents data. Because if you the rest is called chart junk, right? So if you look at a plot made by Excel, for example, there's no use for that background. There's no use for these vertical lines. And let me zoom in a little bit. Voila. And actually we can improve this plot a lot until we have something like this, which is like a much better plot than the one with all that ink used that is not data ink, right? So this is a concept devised by Edward Tufte. I'm looking if I have the book here that I can show. Nope. So Edward Tufte is one of the big names in data visualization for explanation, to show things to other people. And he calls the data ink ratio is basically 1 minus the proportion of the graphic that you should erase, right? So that's something you need to do, try to maximize the data to ink ratio. Something else is that you have to be aware of the life factor. So the life factor is basically the difference between the size that is shown in the graphic, sorry, the size of the effect shown in the graphic versus the size of the effect in the data. And this is a really good example. This is Steve Jobs from Apple on a keynote talking about the market share of the iPhone. And the iPhone is in green, and this looks more than the purple here, right? Why is this? Well, that is not correct, right? That is because basically it took that pie chart and he flipped it forwards, it tilted it forwards. So this is closer to the audience than this, right? Not only that, he also extruded it a little bit. So here you see this green border at the bottom, right? So it's even more green pixels. So that means that the size of the effect shown in the graphic is bigger than the size of the effect in the actual data, right? So never ever do this. Unless you're in marketing and you want to play with these things, but yeah, I wouldn't. Something that I mentioned before is the 3D, so don't do 3D. There's issues with occlusion, so things that are unreadable, things that are hidden, things that are distorted. For example, here as well, so we have 1, 2, 3, 4, 5 people here. I have no idea what this data is, but anyway. But what are the values? So green, 1, 2, 3, 4. Where's the fifth? And how high is the fifth? We have no idea. Also, same thing with the purple, the third one. Is it higher or lower than the other 4 purples? This one, is it higher or lower than this purple? We have no idea, right? Ice beat memory, that's something I mentioned before, looking at dynamic networks. Focusing context. I'll explain that together with the next one, actually. Overview first, zoom and filter, details on demand. This is like the central mantra in interactive data visualization, right? So that was described by Ben Schneiderman. He passed away, unfortunately, I think 2 years ago. Actually, if you go on the internet and you see those links on websites and they're blue and underlined, right? That's because of Ben Schneiderman. He was in the beginning. He's the one actually thought of doing this. But anyway, so overview first, zoom and filters, detail on demand. Also, always start with your overview. So here, what we see here is airports across the world, right? And we'll actually use that data set in our implementation tutorial as well. So these are all airports, and the blue ones have mainly international flights. The red ones have mainly domestic flights. So you start with the overview, start with everything. And then you can zoom or filter, right? So you can, for example, zoom on this region of South America, and you see this. Or you can filter and only show the blue ones. And then the third phase is the details on demand. So you hover over a certain airport and to show you the details, right? But start with this. Now, coming back to the previous one, focus and context. While showing this, also show this, right? Otherwise, if you only have this bit of the plot, you have no idea what you're looking at. Is this part of Japan, somewhere in Europe, in the US, in Russia? We don't know, right? So you really need to be able to see where this is in the bigger context as well. Yeah, under-engineer if possible. That's something I thought of the moment that I was actually developing this thing. A big difference between data visualization and developing software, right, or creating scripts, is that if you do data analysis using a script, you have to make sure that you capture all the edge cases, right? If you because if you don't catch an edge case, then you might get wrong results, right? But in this case, actually, what I was writing was a system, as an example, the tutorial. We have long distance flights and short distance flights and everything in between, right? And what this would do is, if I moved my mouse to the left, it would only show short distance flights. If I move my mouse to the right, it will only show long distance flights, right? So you'd have that actually change if I go left or right. Now, if I would move across the zero line, right, then all, well, in that version of that script, strange things happened in this plot. So all of a sudden, a lot of points show up if I cross this little border here, right? But because I'm doing visualization, because I look at this, I can think, actually, oh, that makes sense. That's probably because I went negative, right? I went further than zero. But if it's something that you program, you have to capture that, right? More importantly, you have to think about the fact that you have to capture that. So what are all the different edge cases that might exist? And you have to actually program for all of them. Another aspect of under-engineering is actually just show the raw data. See how far you can get with just showing the raw data. I have an example here of a plot made by Ben Fry. And this shows clearly, I should have removed that. So clearly this shows the US, right? So we have the coastlines, we have the big lakes here. We see, well, this is lighter than this, which is actually linked to population. We have cities, so these dark blobs are cities. We have a mountain range here. We have a mountain range here as well. But actually, none of those things are drawn. The only thing that is drawn is roads. So Ben Fry basically took the road data of the US, plotted them, and this is what we see. We don't see the roads, we see the emergent properties, the higher level properties, right? Now imagine, so that's really strong. Imagine that you have that same data set, and you're not allowed to make a visualization. You have the same data set with all the roads, and you asked, okay, write me a script to identify the coastline, or write me a script to identify cities. Good luck. So that's not simple. Something else, another example is actually from my own data. This is my email from 2005 to 2015. And this basically shows going from left to right, there's different days. And going from bottom to top, that's from midnight to the morning, noon, evening, and midnight, okay? And each dot is the moment that I sent an email. So yes, you see here, I get up at a certain point in time and I start working, right? So these are the emails sent out. There's not a lot of emails sent at this range, so that must be lunch, dinner, and then some work in the evening. The summer, that's clear. So I have dinner. You can see when there's a deadline, right? So when I work really late or up until the morning. At that moment, I lived in the UK, and sort of the moment I moved back to Belgium, there's a 1-hour shift. Also, that signal for lunch is gone, almost gone. So either I didn't have lunch, but I did. So probably that's because either I was having lunch behind my desk, guilty, and at the same time, not always lunch at the same time, right? And that's it for this session.